This is Calculus 2 class. Now we're gonna study volumes. There is a three method to find the volume. So first we're gonna work on discuss disk method. What is disk method? It's pre-class quiz. So you understand what this method talking about. First one is, guys, look at this one here. Let's see. Here is a rectangle, guys. Rectangle. This is rectangle. See the rectangle? Here is W gonna be base, R gonna be height. That's the rectangle looks like. Now, you're gonna rotate the rectangle axis of revolution. This one is might be any line, vertical line, horizontal line, any line. We're gonna rotate this rectangle. With the base gonna be W. This is the base. This is height. That's the rectangle, right? But the other way you see it, rotate it over axis revolution, then you're gonna see this disk. Shape looks like this. Now, this W here is base gonna be changed its depth of this disk. R is height to change the radius. We call this is a disk. That's the 2D to the 3D object. Now, how can find the volume of this disk? Volume gonna be, you remember the volume of disk? Base times, base is a circle, base gonna be this volume 3D base is a circle, pi r square, that's gonna be depth or height, that's gonna be W. That's how to find the volume of this disk. So we're gonna use this idea of find the volume of area below the curve rotated of any line, any axis. So first we practice x-axis. Look at this one. This one is the any curve. Blue part is area. We're gonna rotate it yellow rectangle. So this one is base gonna be delta x. Height gonna be r. Height, or we're gonna talk about radius later on, but we're gonna rotate it this axis revolution, rotated here, rotated this one. Then this area gonna be changed into 3D object. So this rectangle right here changed this disk. So all this you're gonna put together, make volume of this 3D object. That's we're gonna calculate the volume. Let's give the how to use this method to find the volume of solid of revolution. So first one is we're gonna use horizontal axis of revolution. This horizontal axis meaning is horizontal is this line, right? Horizontal is here is, for example, this line, right? Horizontal, but we're gonna start with x-axis. Let's start with x-axis, guys. Okay, this is x-axis. So this one is a function. This is a function of y equal rx. So we want to find the volume. And you remember from calculus class, integral is meaning is a sum. So how gonna start here? We're gonna only thinking about one rectangle. You sketch it. How gonna sketch one rectangle? You sketch the rectangle perpendicular to the axis of revolution, one rectangle. This one is a small piece, dx. That's you find it, dx. Then you're gonna find the radius. Radius gonna be this here to here. That's gonna be y. Y is radius, so y equal rx. So previous slide, we see that this volume of this is gonna be pi Rx square dx. So integral means all together we did only one piece of a rectangle, then where to where? A and B. That's find the volume when you do rotated x-axis or horizontal axis of revolution. Another way, guys, very carefully see vertical axis of revolution. That's going to be rotated y-axis, rotated y-axis. So you're going to make rectangle perpendicular to the axis of revolution. Then you're going to have this rectangle. This time, you're going to have delta y. That's going to be dy from calculus class. That's the small base or height for the disk. Radius, right? So this one is going to be from axis. This is going to be x value. X value going to be here, ry. That's the radius. So ry square dy times pi. That's the vertical axis of revolution. This is horizontal axis of revolution. So let's just start with the example for the disk method. Let's start this question. Guys, read very carefully here. So what did it say? Find the volume of a solid obtained by rotating a region bounded by the curve y equals square root of x, x-axis, where to where? 0 to 1. So this is region. I sketch it. This one is y equals square root of x, and this one is x-axis. Where to where? 0 to 1. We're going to rotate this region over the x-axis. So that make a volume, 3D of object. So we want to find the volume. We want to find the volume generated by this region. So how can you start? Make a rectangle right here. This is a rotating axis. You're going to make rectangle perpendicular to the x-axis that you make it. Here is, guys, always this one, guys. This is axis. This one base gonna be dx, small piece, because that's the x-axis. Then what is height? Height gonna be this is y value. This is y value, but here y value is radius. So disk method say volume gonna be integral. X value is 0 and 1, 0 and 1, that's the here. Pi r, r is gonna be right here, that's the r. R square root x square, r square times base gonna be dx. That's you set it up to this volume, guys, 0 and 1. Guys, make sense? So how to calculate this one? Pi gonna be outside, 0 and 1, x dx. So this one is antiderivative 1 over 2 x squared, 0 and 1, pi 1.5 minus 0. This one is pi over 2. So volume of this solid generated by this region gonna be pi over 2. Okay, let's try another example. This example, we using vertical axis of revolution. Previous example, we use horizontal axis of revolution. So here's a look at this. The example is we're gonna find the volume of a solid obtained by rotating region bounded by curve y equal x cube, y equal 8, x equal 0. So that's how I sketch it. This is y equal x cube. This is y equal 8. Here is gonna be x equals 0 is the y-axis. That's make a reason. So this one is rotated y-axis. Then we're gonna sketch the rectangle perpendicular. Guys, remember the perpendicular rectangle. So volume gonna be, okay, pi perpendicular here. What is the base of this one or height of this? Guys, look at this. This is dy because rotating over y-axis, horizontal and vertical axis of revolution, that's going to be dy. So here going to be radius square. We're going to find the radius. Okay? What is the radius going to be here to here? This one is x value, not the y value, guys, x value. So we have to solve this one is x. So y equal x cubed, x gonna be y 1 over 3. So that's gonna be radius. Y gonna be 1 over 3. So how can solve it? This one is the, oh, I forgot the boundary. Boundary is y value 0 and 8. 0 and 8. Pi integral 0 and 8 y 2 over 3 dy. Let's use power rule. Pi 2 over 3 plus 1, that's y 5 over 3. Here is 3 over 5. Where to where? 0 and 8. So this one is 3 pi over 5. You plug in the 8 is 5 over 3 minus 0. So 8 pi over 3 gonna be 2 to the cube, 5 over 3, then 2/5. That's gonna be 32. So you have 3 pi over 5 times 32. That's gonna be 32 times just 3, 96 pi over 5. Everyone understand that? That's the key part of disk method. Let's practice disk method. Guys, first identify which axis of revolution you draw the rectangle perpendicular to the axis, then find the radius and find the volume, guys. Let's try this one, guys. So what are you going to do here, guys? Find the volume of a solid to generate the body evolving the region bounded graph of equation about x-axis. So x-axis rotates this one, guys. So we're going to sketch the rectangle perpendicular. Let's sketch the perpendicular right here. Did you sketch it? So find the volume, pi, integral, interval of x, that's base gonna be dx, 0 and 2, 0 and 2. All you have find it height. Height, this case gonna be, this one is height, this is y value, y equal x square. So here is x square, radius square. That's you're gonna find it, this one, pi, integral 0 and 2, x fourth power dx. Here is a pi, x fifth power over the 5, 0 and 1. This one is pi over 5. So you find the volume, excuse me, for this question. Let's practice find the volume by using axis of vertical lines, okay? Find the volume of solids generated by revolving the region bounded by graph of equation about y-axis. Guys, keep in mind this time is y-axis. You're gonna sketch the rectangle perpendicular. This is y-axis. Rectangle should be this direction. Okay, that's the perpendicular. So this one gonna be dy. Now radius gonna be this value. This is gonna be x. But this is y equal x square. So y equal x square, we're gonna find the x, solve for x. X gonna be square root to y. Okay? So now volume gonna be pi integral interval. You're gonna find the interval by look at this one. This is dy. So dy, this y represents you need interval of y. Interval of y is 0 and 4. 0 and 4. Here is radius is x. X gonna be square root to y. So square root to y square. Before you move on, check it out. This is variable y. Here is y. That's you do the y setup. So let's solve it. Pi integral 0 and 4 y dy. Power rule gonna be y square over 2, 0 and 4, pi 16 over 2 minus 0. That's gonna be 8 pi. Now we finished the disk method. Let's work on the Washer method.